Here's a number that sounds made up. For most of human history, if you were born, your odds of seeing your fifth birthday were somewhere close to a coin flip. Not in some uniquely brutal corner of prehistory, pretty much everywhere, for pretty much all of history, until about 200 years ago. And yet, you're here. Not just you, an unbroken chain of successful survivals stretching back roughly 10,000 generations, every single one of them ending in a child who made it. One failure, anywhere in that chain, and this video doesn't exist, and neither do you. So either your ancestors got extraordinarily lucky, over and over, for 300,000 years, or they figured something out, something systematic, something that worked often enough, against odds that should have made it impossible. They did figure it out, and the answer isn't a survival tips listicle. It's closer to an engineering solution, a set of overlapping, mutually reinforcing behaviors around birth, feeding, carrying, sleep, and community that modern science is still in the process of reverse engineering. Some of what we're learning is honestly humbling, because in a lot of ways, industrialized society threw large parts of this system away without realizing what it was throwing away. Let's take it apart piece by piece. Start with the most basic fact. Human infants are unusually, almost absurdly helpless. A newborn wildebeest is standing within minutes and running with the herd inside a day. A newborn chimpanzee, genetically about 98% identical to us, can grip its mother's fur and hang on within hours of birth. A human newborn can't lift its own head. It can't regulate its temperature. It can't do anything except cry, and cry it does. The textbook explanation for this, the one you've probably heard, is called the obstetric dilemma. The story goes like this. Walking upright on two legs narrowed the human pelvis. A narrower pelvis means a narrower birth canal. So evolution supposedly struck a compromise. Kick the baby out early, before the skull gets too big to fit, and let the rest of its brain development happen outside the womb, exposed and unfinished. It's a tidy story, and for decades it was the accepted answer. Except more recent research has quietly dismantled it. Anthropologist Holly Dunsworth ran the numbers in 2012 and found the pelvis story doesn't actually hold up. Wider hips don't meaningfully hurt walking efficiency, and human pregnancies aren't even short for a primate our size. What she found instead is that pregnant women approach the absolute ceiling of how many calories a human body can metabolically burn per day right around the time of birth. The real limiting factor isn't the width of the birth canal, it's the mother's metabolism running out of road. Push gestation another few months to let the baby finish cooking, and you'd need a body that can burn calories faster than a human body seems able to. So birth happens when it happens, not because the exit is too narrow, but because the fuel tank hits empty. Either way, the result is the same. A baby that arrives with roughly a quarter of its adult brain built and 3/4 of its neurological development still to come. For comparison, a newborn chimpanzee arrives with something closer to 35 to 40% of its adult brain already formed, meaningfully further along than we are the moment we're born. The rest of that unfinished development happens completely out in the open, with an infant completely unable to survive alone for even a few hours. And that single fact reframes the entire question. How did ancient humans keep kids alive was never actually a question about individual parenting skill. Biologically, it couldn't be. A human infant is not a solo survivable organism. It's a joint project, or it's nothing at all. Anthropologist Sarah Hrdy spent decades studying primate mothering, and she noticed something odd about our species compared to chimpanzees or gorillas. In almost every other great ape, a mother who lets a stranger touch her infant is taking a serious risk. Humans are the opposite. We are, as a species, remarkably comfortable handing a baby to someone else, a grandmother, a cousin, a total stranger at a family gathering. Hrdy argued this isn't incidental. It's a specific evolved strategy she called cooperative breeding, built around what researchers call alloparents, anyone who helps raise a child who isn't that child's biological parent. Field studies of the Hadza in Tanzania, led by researchers Alyssa Crittenden and Frank Marlowe, documented exactly how this plays out day to day. Women in a camp regularly swap childcare duties with women they aren't related to. One watches the children while others forage, and the arrangement flips the next day. No ledger, no expectation of exact repayment. It's not charity, it's infrastructure. Grandmothers, specifically, show up again and again in this research. In the 1990s, anthropologist Kristen Hawkes proposed something now known as the grandmother hypothesis, that human menopause, genuinely rare in the animal kingdom, evolved because older women who stopped having their own children and redirected that energy into grandchildren produced more surviving descendants overall. Hawkes' own fieldwork with Hadza grandmothers found their foraging output tracked closely with how much extra help their daughters needed. It's a compelling idea, and it's also one that's still genuinely argued over in academic circles. Some researchers think the timeline doesn't add up, or that the effect is real but the mechanism is different. Biologist Lynette Sievert has argued the causation might even run backward, that women's egg supply simply failed to keep pace as human lifespans stretched longer for other reasons, and menopause is a side effect rather than something evolution specifically selected for. Nobody has fully settled it. That argument is honestly a good sign. It means people are still checking the math instead of just repeating the headline. Grandmothers weren't the whole story either. Anthropologist Barry Hewlett spent years living with and studying the Aka people of Central Africa, and found that Aka fathers keep their infants within arm's reach for roughly half of daylight hours, a level of paternal closeness that would be unusual in most industrialized households today. Layer in aunts, uncles, older siblings, and unrelated adults who all took turns holding, feeding, and watching young children, and you get something anthropologists sometimes call a distributed child, a kid whose survival never depended on any single adult not having a bad day. Now the practical side. What did ancient children actually eat, and how? Breastfeeding in ancestral human societies looked almost nothing like the modern default. Cross-cultural and comparative primate research puts natural weaning age somewhere between 2 and 4 years old, which sounds extreme until you notice the World Health Organization still recommends breastfeeding continue to at least age 2. Frequency was constant too. Hunter-gatherer infants nursed roughly every 15 to 20 minutes across the day in small bursts, not on a schedule but on demand. That constant nursing did 3 jobs at once: nutrition, stress regulation, and, through a hormonal mechanism called lactational amenorrhea, birth control. It's a big part of why children in foraging societies are naturally spaced 3 to 4 years apart. You weren't supposed to have 2 infants competing for the same lap. And breastfeeding wasn't necessarily restricted to a child's own mother. Historical and anthropological records from cultures on every inhabited continent describe wet nursing and milk sharing, women breastfeeding each other's children, sometimes out of necessity when a mother died or fell ill, sometimes just as an everyday act of mutual aid. The practice was common and formal enough in the ancient world that Mesopotamian law codes on the clay tablets of Hammurabi included specific rules governing paid wet nurses, and Roman gravestones sometimes named the wet nurse right alongside the family. Breast milk functioned, in a very real sense, as a shared community resource, not private property. Solid food introduction gets stranger by modern standards. There were no jars of pureed carrots. The most widespread method for softening food for a baby's first teeth-free months, found across an enormous range of ancient and traditional cultures, was pre-mastication, an adult chewing food and passing it to the infant mouth to mouth. It sounds alarming through a modern hygiene lens, and researchers are still actively studying what it does, but early findings suggest it may transfer beneficial oral bacteria from caregiver to infant that support early immune development, alongside the obvious bacteria you'd expect. Chimpanzees do this too, which suggests it's not a human invention so much as an inherited primate behavior that predates our species entirely. Beyond that, kids got whatever calorie-dense, easy-to-chew food the group had: cracked bone marrow, mashed roots, small scraps of fish or meat, and for what it's worth, dental analysis of hunter-gatherer remains generally shows fewer cavities than early farming populations, who leaned hard on starchy grains. Picture the actual logistics. You're foraging, walking several kilometers over rough terrain, and you have an infant who cannot regulate its own body temperature, cannot defend itself, and announces distress to every predator within earshot the moment it's left alone. The solution ancient humans landed on was continuous physical contact, carrying the infant against the body essentially all day, every day. There's real biology backing this up. Newborns have a startlingly strong grip reflex. Press a finger into a newborn's palm and it clamps down hard enough to support real weight, almost certainly a leftover from an evolutionary past where infants needed to cling to a caregiver's body directly. And it's not just reflexive. Being carried appears to regulate an infant's physiology in measurable ways. A 1986 randomized controlled trial by pediatric researchers Hunsaker and Barr found that simply instructing mothers to carry their infants more throughout the day, not even using a carrier, just more time in arms, cut crying by 43% overall at 6 weeks old, with the biggest drop during the notoriously difficult evening hours. That's not a folk remedy. That's a clinical trial with a control group. Ancient infants were very likely carried during nearly all of their waking hours and slept in physical contact at night. The crib, the nursery, the idea of a baby spending long stretches of the day alone in a bouncer or a swing, these are recent inventions, historically speaking, and they represent a genuine departure from how the human nervous system evolved to expect its environment to feel. Sleep followed the same logic. In essentially every documented hunter-gatherer society and the overwhelming majority of traditional cultures worldwide, infants sleep in physical contact with a caregiver. Not in another room, not in a crib, but against a warm body, all night. Anthropologist James McKenna, who has spent decades researching this at Notre Dame, coined a specific term for the version involving a breastfeeding mother, breast sleeping, deliberately distinct from generic co-sleeping, because in his research the breastfeeding relationship itself is what makes the arrangement work safely, with mother and infant tuned to each other's movement and breathing across the night. His research proposes that a sleeping adult's breathing rhythm and small movements may help stabilize an infant's own breathing during a developmental window when that regulation isn't yet reliable on its own. This is a genuinely sensitive topic in modern parenting discussions, and it's worth being precise about it. The real safety risks associated with bed sharing in contemporary Western contexts, soft bedding, caregiver impairment from alcohol or sedatives, sleeping on a couch, are well documented and real. Those aren't ancestral conditions, though. On a firm sleeping surface, with a sober, responsive caregiver, in a cooler ancestral sleeping environment, the risk profile is a genuinely different scenario than the one modern safety warnings are built around. The point isn't that co-sleeping is simple or risk-free everywhere. It's that the isolated nursery, a baby sleeping alone, in another room, out of earshot, is an extremely new experiment in the context of our species' history, and infant physiology hasn't had time to catch up to it. Here's where the story needs some honesty. All of this, the carrying, the breastfeeding, the extended family, the co-sleeping, worked well enough to keep our species alive for 300,000 years. It did not work anywhere close to perfectly. A 2021 cross-cultural analysis of hunter-gatherer populations found child mortality before puberty averaging around 49%, with roughly 27% of infants not surviving their first year. That's genuinely brutal by modern standards. But here's the twist that a lot of pop science retellings leave out. Agricultural and early industrial populations weren't meaningfully better off. Church records from 1700 Sweden show roughly 40% of children dying before age 15. Skeletal populations from Iron Age Majorca and ancient Peru show child mortality close to 50%. The grim reality is that catastrophic child mortality wasn't a hunter-gatherer problem. It was a pre-germ theory, pre-antibiotic, pre-vaccine problem, and it applied almost uniformly across human societies for thousands of years, regardless of how people got their food. What actually crushed child mortality, down by something like 96% since 1800, wasn't a parenting technique. It was clean water, vaccines, and modern medicine. It's also worth correcting a specific myth here, because science corrected itself on this one recently. Archaeologists have long pointed to the sheer number of infant burials at ancient sites as proof that ancient parents were almost numb to child death, that losing a baby was simply routine and unremarkable. A 2023 reanalysis by researcher Claire McFadden flipped that interpretation. Comparing burial data against modern population statistics, McFadden showed that a high number of infant graves mostly just reflects a high number of births. High fertility populations naturally produce more infant deaths in absolute terms, even if the death rate itself isn't unusual. In other words, those burial grounds are evidence people were having a lot of babies, not evidence they didn't care when they lost one. And there's direct evidence they did care, deeply. Infant burials across the archaeological record are frequently arranged with real deliberateness. Grave goods, protective objects, sometimes flowers or ochre. Now, it's worth flagging that even this kind of evidence needs to be checked carefully. The famous flower burial at Shanidar Cave, long cited as proof Neanderthals mourned their dead with floral tributes, was recently re-examined, and the pollen clumped under the skeleton turned out to most likely be the work of burrowing bees, not grieving mourners. Good science means being willing to walk that back. But plenty of other burial evidence, deliberate positioning, tools, ornaments placed with children's remains, holds up under scrutiny. Alongside physical care, virtually every human culture on record developed rituals specifically around birth and childhood. Naming ceremonies, protective charms, mourning rites. Anthropologists think these did real social work, publicly assigning responsibility for a child's welfare to the whole group, and giving people a structured way to grieve when inevitably a child didn't make it. They also reached for medicine with what they had. Chimpanzees self-medicate with specific plants, so the behavior likely predates our species. Willow bark, the original source of aspirin's active compound, was used for pain and fever for millennia. Honey served as an antimicrobial wound dressing in ancient Egypt. Garlic has genuine antimicrobial properties that people identified empirically, centuries before anyone understood why. None of it could touch bacterial meningitis or severe dehydration. But it wasn't nothing, and it represents generations of careful, accumulated trial and error. So here's the uncomfortable synthesis. On the biomedical side, modern civilization's advantage over the ancestral world isn't close. Vaccines, sanitation, antibiotics, neonatal medicine, these have done more to keep children alive than every ancestral behavior combined. Nobody sane is arguing for a return to a coin flip survival rate. But on the behavioral and social side, the actual day-to-day architecture of how a child is cared for, it's a much murkier trade. The extended, overlapping network of caregivers that cooperative breeding provided has largely been replaced, in much of the industrialized world, by a nuclear family that's often geographically isolated from grandparents, aunts, and uncles. Constant physical carrying has been substituted with bouncers, swings, and screens engineered specifically to occupy an infant without anyone holding it. The shared nighttime sleeping environment has been replaced by a separate nursery and a fairly recent cultural discomfort with dependence itself. None of that happened because anyone stopped caring about children. It happened because of urbanization, dual-income households, and the slow dissolution of extended family living arrangements, economic and social shifts that had nothing to do with child welfare as a goal. But the resulting cost shows up in the data anyway. Rates of postpartum depression, infant sleep problems, and parental burnout in industrialized nations are high and persistent in a way that maps uncomfortably well onto how thin the support network has become. It's probably not a coincidence that the countries doing the most, through policy, to rebuild some version of that support, paid family leave, subsidized childcare, community health visitors checking in on new parents, tend to be the ones where parents report faring better. It's a modern bureaucratic substitute for what a hunting and gathering ban did automatically. But the underlying need it's answering is exactly the same one our species has had for 300,000 years. Strip away every specific detail, the breastfeeding, the carrying, the co-sleeping, the plant remedies, and one pattern sits underneath all of it. Ancient human children survived embedded in dense, overlapping social contact, not in spite of needing that much help, but because the species had fully accepted that one adult, alone, was never going to be enough. It wasn't sentimentality. It was the actual engineering solution to an animal born catastrophically unfinished. We've since solved the biomedical half of the problem more completely than any generation in history. The social half, the web of hands a child is supposed to grow up inside, is the part we're still quietly relearning, one study at a time. Ancient parents didn't have antibiotics, ultrasounds, or car seats. What they had was each other, distributed thickly enough around every child that no single failure could end the chain. For 300,000 years, that was enough to get you here.